Hello, this time we're going to discuss about solving system of equations using substitution. In solving system of equations using substitution, we need to follow several steps. Number 1, solve one equation for one variable. Solve for one equation for one variable means if you're going to solve for y, isolate y. If you're going to solve for x, then isolate x. If you're going to solve for a, then isolate a. Okay? The next one, substitute the expression from step 1 into the other equation. So whatever will be in step 1, you're going to use that in step 2. Okay? The next, simplify and solve the equation. Number 4, substitute back into either original equation to find the value of the other variable. Then 5, check the solution if both equations of the system. Okay? We have here example number 1. The first equation is y equals 4x. The second equation is 3x plus y equals negative 1. Okay, going back to the different step. Step 1, solve one equation for one variable. Okay, so we have here y equals 4x, equation 1. Y equals 4x. Why? Why are we going to use this? Because y is already solved, meaning y is being isolated. Okay? That is, for step 1, we use equation 1. So in step 2, we have substitute the expression from step 1 into the other equation. In step 1, we use equation 1. Therefore, in step 2, we're going to use the second equation. 3x plus y equals negative 21. It says here, substitute the expression from step 1 into the other equation. This is your equation 2, okay? 3x plus y equals negative 21. Instead of writing y, we are going to substitute 4x because it says here y equals 4x. So we have there 3x plus 4x equals negative 21. Again, instead of writing y, we substituted it by 4x. Okay? Then after that, simplify and solve the equation. 3x and 4x are similar terms. Therefore, we can combine it. 3x plus 4x equals 7x equals negative 21. Then we are now going to solve it. We're going to divide both sides of the equation by 7. Therefore, x equals negative 3. Negative 21 divided by 7 is equal to negative 3. Okay? We now have the value for x. Our problem now is the value for y. Okay? In step 4, we are going to substitute back into either original equation to find the value of the other variable. Again, we already have the value for x, which is equal to negative 3. In order to find for the value of y, we need to use either equation 1 or equation 2. That is in step 4. So we have here 3x plus y equals negative 21. We use equation 2. What will be the next one? we're just going to substitute the value of x. 3, the value of x is negative 3. So instead of writing x, we're going to write negative 3. Plus y equals negative 21. So 3 times negative 3, that is equal to negative 9, plus y equals negative 21. We are solving for y, so we need to get rid of negative 9. We need to get the opposite, which is positive 9. And here is also positive 9. So negative 9 plus 9, that will be 0. So y now equals negative 12, because negative 21 plus 9, that is equal to negative 12. Therefore, the solution of the given system is negative 3, negative 12. Okay? How sure we are that that is the correct solution? We can by just checking it. Okay? You're going to check the solution on both equations. So you're just going to plug in the first equation. Y equals 4x. Your y is negative 12 equals 4. Your x is negative 3. So negative 12 is equal to negative 12. Is the statement correct? Yes. The next one, we have 3x plus y equals negative 21. Just plug in the value of x, which is negative 3. The value of y, which is negative 12, equals negative 21. 3 times negative 3, that is negative 9. And then plus negative 12 is equal to negative 21. So negative 21 equals negative 21. Is the statement correct? Yes. Therefore, negative 3 and negative 12 is the solution of the given system. Okay? The next one we have here. X plus y equals 10 and 5x minus y equals 2. Based from the first step, we're going to solve one equation for one variable. You can use either equation 1 or equation 2 in step 1. Okay? So in here, we're going to use equation 1. You're going to solve one equation for one variable. Okay? So we have y equals negative x plus 10. We solve for y. How does that happen? You need to get the opposite of x, that is negative x, and then negative x. So x plus negative x, that will be 0. Bring down y equals negative x plus 10. Your y is isolated. So that is now in step 1. Step 2. Okay. In step 1, we use equation 1. Therefore, in step 2, we're going to use equation 2. You have 5x minus y equals 2. So you are now going to substitute your y. Instead of writing y, we are going to write negative x plus 10. So you have 5x minus, you need to enclose this one, negative x plus 10 equals 2. So you now have here 5x, negative times negative, that will be positive x. And then, okay, again, that is 5x, negative times negative, that is positive x. Then negative times positive, that is negative, equals 2. Then after that, we're now going to simplify. Let us combine this one. 5x plus 1x, that will be 6x, minus 10 equals 2. Okay? So we need to solve for x. We need to move this. We need to get the opposite. And the opposite is positive 10. So you're going to write positive 10 on both sides of the equation. So you now have 6x, that will be 0. So 2 plus 10 equals 12. Dividing both sides by 6. So x now equals 2 because 12 divided by 6 equals 2. So you now have the value for x. Our problem now is the value for y. Then, what are we going to do? We can use either equation 1 or equation 2. So in here, we use equation 1. You are going to substitute the value of x based from the previous computation, wherein x equals 2. Okay? So you now have 2 plus y equals 10. Get the opposite of 2, that is negative 2. And then you have here negative 2. So we have y now equals 8. Okay? So we have now 2 and 8 as the solution of the given system. Then, to justify our answer, let us do the checking. You're just going to substitute the value of x and y. X plus y equals 10. Your x is 2 plus your y is 8 equals 10. 2 plus 8 equals 10 and they are equal. So the statement is true. The next one, we have 5x minus y equals 2. 5, your x is 2 minus your y is 8 equals 2. 2 times 5 is 10 minus 8 equals 2. So 2 equals 2. The statement is true. Therefore, the solution of the given system is 2 and A. Okay? There are instances that you will come up with like this. 2 equals 2 and we have 8 equals 2. If you happen to have 2 equals 2 or 3 equals 3, then the system has infinitely many solutions because they are equal. Okay? There are also instances that you will come up with this computation. 8 equals 2. Are they equal? No. Or it can be 3 equals 0. Are they equal? No. If you happen to encounter this kind of expression or equation, then the system has no solution. If they are equal, the system has infinitely many solutions. If they are not equal, then the system has no solution. Okay? Let us try some example. We have this one. X equals negative 2y plus 4 and 3.5x plus 7y equals 14. Based from the steps. Step 1. Solve for a variable. We have here, we're going to choose equation 1. X equals negative 2y plus 4. This is now the first step. Your x is being solved already, so no need to solve for x. Okay. Second step. In first step, we already use equation 1. Therefore, in second step, we are now going to use equation 2. So you have 3.5 x plus 7y equals 14. Okay? That is the second equation. 3.5x plus 7y equals 14. Then after that, we're going to substitute. And close. Instead of writing x, we are going to substitute this one. We have to write negative 2y plus 4 plus 7y equals 14. Okay? And then solve. 3.5 times negative 2. So that is positive times negative, that is negative. 2 times 5, that is 10. Carry 1. So 2 times 3, that is 6. Plus 1, that is 7. So 7.0y. Positive times positive, that is positive. We have 4 times 3.5. 4 times 5, that is 20. Carry 2. So 4 times 3, that is 12. Plus 2, that is 14. 1 decimal place. Plus 7y equals 14. Let us rewrite the numbers without zeros. So you now have negative 7y plus 14 plus 7y equals 14. Okay? So we have here, we can combine negative 7y and positive 7y. So you have negative 7y plus 7y plus 14 equals 14. Let us now combine similar terms. Negative 7y plus 7y, that will be 0. So what is left here? 14 is equal to 14. Is there any variable left on the equation? No. So you just have 14 equals 14. Are they equal? Yes. Again, based from our previous statements, if we come up with this kind of equation, 14 equals 14, meaning to say the system has infinite number of solution. Okay? Infinite number of solution or infinitely many solution. Okay? Can you follow? The next one we have here. Y equals 3x minus 11. Y minus 3x equals negative 13. Going back to the steps. Step number 1. Solve for x or solve for y. This is our first equation, and we have here the second equation. Try to observe. Your y here is isolated. So in step 1, we are going to use equation 1. Why? Because your y is already isolated. Okay? Isolated. Next, step 2. In step 2, we are going to use equation 2. Y minus 3x equals negative 13. Okay? So we're going to plug in or substitute. Instead of writing y, we are going to substitute it by 3x minus 11. So let us enclose. Again, instead of writing y, we're going to replace it or substitute it by 3x minus 11 based from the first step. Minus 3x equals negative 13. Okay? So you now have 3x minus 11 minus 3x equals negative 13. Okay? Combining similar terms, we can combine this one. So 3x minus 3x minus 11 equals negative 13. Okay? 3x minus 3x, that will be 0. So no need to write it. So you now have negative 11 equals negative 13. Is there any variable left on the equation? None. Is negative 11 equal to negative 13? No. Okay? So if you will come up with this kind of equation, since negative 11 is not equal to negative 13, therefore, the system has no solution. Okay? Can you see now the difference? Based from our previous example, they are equal, then you're going to write it infinitely many solutions. But in this example, negative 11 is not equal to negative 13, therefore, the system has no solution. Okay? Any question about this?